In this tutorial, we are going to explore the basics of Godot Engine while building a 2D game. We are going to explore Godot concepts like 2D scene and node system, understanding how Godot organizes game elements, and we are going to use some of the most common 2D nodes in Godot like Sprite 2D, Node 2D, Collision Shape 2D, timers, and many more. We are also going to use signals for connecting game events, adding sounds to our game to make it more interactive, and we will first write our first code using GDScript. All of that in this video, so without further ado, let's head to the tutorial. Alright, now head over to your favorite search engine and search for Godot. And head over to their website. You can either click this download latest or this download. Godot is very easy to download and install. Their website will automatically detect your operating system. As for me, I'm on Windows machine, so if I click this, it will be downloaded. Okay, it's like E65 MB. Now head over to your download files. Depending on your operating system, you can just extract this. Right click and extract like that. And just like that, you are now downloaded the Godot engine. Just very easy. And now after opening the Godot, you'll get this project window manager and we are ready to build our first game. But first, before we create our game, let's click the settings and I'm going to change my this. You don't need to do this, but I'm going to change my display scale to 125% so that this video, the code is larger so that you can see it clearly. And my naming convention is yep, by default Pascal case. Let's going to restart it now, quick. Okay, and now it's a little bit bigger. You can also change the theme if you'd like, but I'll leave it to default for now. Now we're ready to build our game. Just click this create here. Obviously, we're going to name it Gym Collector, but by default, it will going to name new game project, and we're going to create a new game project on our documents folder. I'm not going to. I'm going to save it on documents folder, but I've created a on my documents. I've created a new folder so that it won't be too messy. I created Godot project tutorials, and the Gym Collector project will be going to save here. Now I'm going to click this browse and select this Godot project tutorials. And we're going to name it Gym Collector. You can save it anywhere, any file system or any folder you want. And I'm going to leave the other option to default. Just click this create. Project settings. And now our game has been created, the Gym Collector. And if you're new to Godot, it might be a little bit intimidating, but we'll get over this one by one. At the top, we've got this top view. Basically, you can switch from 3D to 2D, and later on, we'll use this script also here. And from the left side, we have this scene menu, and we have this file system. Now, from this period, I hope you've downloaded the assets that I put on the descriptions below. This is the gym collector assets that we are going to use on this game. We've got these four sounds. Click 1 and click 2, the explode, the game track. I've also put their space background, which you can choose any one of them. And now we are going to import our gem collector assets into our game. Just copy this gem collector assets and head over to your game project. Under the file system, click the list and right click it and click this open in file manager. After clicking that, it will redirect you to your project folder and then paste or control V the assets. Now, I actually want to name it as assets. And when we head over to our project, the assets will be imported. And yeah, just like that, we've now imported our assets and ready to build our game. Just a quick overview. In this tutorial, it will have just three scenes. The first scene is a game scene. Now add this, click this 2D scene, and we'll name it as game scene. Now we are going to add the background inside this viewport. Click this game scene and click this plus icon to display a graphics in our game. We're going to select the sprite. Um, Sprite is one of the common 2D nodes in Godot. It is used to display graphics in our game. So select that. Now you can select any of these option below for the background. I'll select the third option. And as you can see here in our sprite today, we have this texture. We are going to drag and drop this space background into this empty texture. Let's do that. Drag and drop this one into the texture. And after that, we've got this background. We are going to save this scene and we are going to play this our game to test it. But before that, head over to project, click this project here, project settings, and search naming, and under the editor, select naming. The scene name casing is snake case. It is a personal preferences, but I like to change it to Pascal case. Yep, but it's up to you if you follow this one because snake case and Pascal case, there's nothing wrong with that. But for me, I'll select Pascal case. Close this one, and we are now ready to save this scene. Control S. These are our project files. Select this create new folder icon and add scenes. It is a best practice that to add the scenes, it should be all under the scenes folder right now. And as you can see, it is now the game scene automatically named by Godot since our node is game, name game. After that, since let's create another folder, game, okay, and then save this one. So if you go here in our scenes folder, we've got the other folder game, and inside that game is the game scene. Right. Now we are going to test this first. Just click this play icon. There's a pop-up. Just select current scene. Now, as you may observe, our game is kind of stretched. It is because it is way too big for our viewport. As you can see this one, this is our viewport, so this background is too big. So what we are going to do is to fit this background into our viewport. To do that, we are going to resize this background here. Yes, but if we are going to resize this directly, we have this aspect ratio is not equal. So to resize that correctly, please select the shift K in your keyboard and then resize this. That way, the aspect ratio is the same. Also, you can go here to node, this one, click this transform, and then there's an aspect ratio lock and unlock. Just keep it locked and you can type 0.6, and the Y will also be same with X, and you can type 0.6, and the Y will also be same with X, and you can fit it in our viewport just like that. Fit it. Sorry, I'm a bit perfectionist, so okay, right. Let's play this. Right, we have now our background perfectly fit into our game. Great, we have now our basic game scene. The next step is to add another scene, which is the paddle scene, and we are going to use this paddle sprite here, paddle graphics, into our scene. To add the paddle scene, we are not going to use the 2D scene, but the area 2D scene. Yep, just search area 2D, and area 2D. Why area 2D? It's because our paddle scene here, a simple mechanics. we are going to use the area 2D node for this one because this paddle will going to collapse later on in our gym scene. So area 2D, it will detect the overlaps for collision. Now, let's go back to our game, select this area 2D, and it has a warning. This node has no shape. Well, obviously, we're going to add the sprite here, sprite 2D. As you may remember, sprite 2D displays an image or texture. So we can select this and again, drag and drop this one into the texture. Okay, we have now our paddle here, and we still have a warning. Yep, if we have area 2D, it should have the some sort of collision. So we are going to search that collision. It has a collision polygon 2D and collision ship 2D. This one for the basic 2D scene, we are going to select the collision ship 2D. It has another warning. A ship must be provided for collision ship 2D to function. Okay. So here, select this one, this collision ship 2D, and select this shape. For that one, I guess it's best to select this capsule shape, this one. Select this capsule shape, and we are going to put this in the sprite 2D body. All right. To do that, we are going to fit that here. You might try this one, but it is going like this one. It's a bit weird. So to fix that, you are let's go to the node 2D here and select this transform, this one. As you can see, there's a property rotation. Let's rotate it 90 degrees like that and fit this on our assets to have e collisions later on into the gym. Okay, just fit it. You can use your arrow keys. Yep, just like that. And then click save, Control S. Let's go back. We are currently on the game scene folder. Let's go to parent folder, this one, scenes, and this is the game scene. Add another folder called paddle scene. Okay. And then inside this paddle scene, let's rename this to, oh, it's area 2D because we didn't name this to paddle. But we'll name it as paddle. Click save and also let's rename this area 2D to paddle. To rename, just double click it, paddle, just like that. And if we go to our file system, we get now the game scene and the paddle scene. All right, we have now our basic game scene and a basic paddle scene. The next step we are going to do is the gym scene. I encourage you to create the gym scene on your own. It is identical with what we've done on the paddle scene. All right, now let's do this together. Click empty. Again, since it will going to collide with the paddle, we are not going to choose the 2D scene, but we are going to select the area to 2D, and we are going to, you just need to select one of these gym. But first, let's add the sprite to the node here. It will display the graphics or the picture of the gym, and then again, we've done this many times. Select one option here. I'll select this one and drag and drop here that one in this texture, right? As you may observe, there's still a warning. What is that? Yep, you've guessed it. We are going to add the collision shape 2D. And for that, there's a warning because we are going to cover this sprite with our collision shape 2D. Okay, head over to inspector, collision shape 2D, and select the shape, the proper shape for this one. As you can see, there is no gem here or diamond shape, but we have the rectangular shape in which we can cover this one by go to node 2D, select the transform, and by rotating it to 45 degree like that. So it come from the square to this diamond. Just fit that to our sprite here. Actually, it's a bit hard because it's blue, but yeah, let's try that. Let's try our very best to cover that. Hmm. Okay, that will do. We've got now, there's no warning here, and we've got our gym here. Now, let's going to save it. Click save, one up above because we're on the paddle. And in the scenes folder, we are going to add new folder. Let's name it e gym. And here we are going to save that. But first, let's rename this to gym. It's not name as gym because in our here in the scene here it is still area 2D. That's why it's not gym here. But yep, let's save that and then rename this to gym. Okay, save. All right, we have now a game scene, a paddle scene, and a gym scene. The next step we are going to do is to instantiate this paddle and the gym into our game scene. Okay, basically to display this paddle and gym into our game scene because as of now it's just a beautiful background here, very lonely. So we are going to instantiate this paddle and gym. To do that, make sure to click this game scene, and here as you can see this one, we are going to instantiate the child scene. Just click that one. We are going to select the scene which we are going to instantiate. First is the paddle. Okay, now we are going to place this paddle at the bottom of this background here because it's going to collect all the gem that are going to fall here and from above. Okay, and now we are going to oops. Okay, um just a little tip for this game sim. We can actually click this background and then select this lock so that we cannot move this accidentally. If we move this, we cannot move this. Okay, so place it anywhere here. I'll place that here, and then also click this game and instantiate the gem also. Click the gem, and we are going to place that somewhere in here. Okay, click save and let's run the project. Right, as you can see, we have now this paddle here ready to collect this gem and this gem ready to fall down. In the next step, we were going to introduce script for the very first time. Let's run the project. The idea is we will make this gem falls down at the bottom of our screen. So we are going to attach a code or a script in this gem to do that. And later in this video, we will also going to attach code or script in our paddle node so that we can control it from moving to the left and moving to the right. For now, let's focus on attaching a script on this node. Let's close this one, and to attach the script of that node, let's go to the gym scene, and at the top, let's click these paper plus icons. We'll select the GDScript as our preferred language. GDScript is a programming language that was created and designed specifically for Godot, so they are very compatible. Though we can also use other languages like C++, but in this tutorial, we were going to use GDScript. Inherited from Area 2D. As you may remember, this gym scene, this one is an Area 2D node, so it inherits Area 2D, not a node 2D. Let's leave the other options here as default, except this one. We'll make this a big letter G, gym.gd, and let's create the script. Right now, we have this template code given to us by Godot. We have these two functions. The ready function, it runs once every when the node enters the scene for the very first time. Think of it like a setup function. It only runs once. And here, the process function, it runs every frame. So it always runs as long as the node is active. And the delta here is the elapsed time since the previous frame. Delta keeps our the movement and the animation of our game smooth and consistent across different frame or different devices, because different devices may have a different frame rate. So by using delta, it keeps it consistent and smooth. Okay, let's make our gym falls down at the bottom of the screen. But before that, make sure that your script is attached to this area to the node here. To know that, you'll see this icon, paper icon here. It means that it was attached to this area to the node. That means all the properties of this gym scene, like the node to the position, rotation, scale, and skew, we can manipulate it inside our script. So we can actually delete the pass, and as I've said, we can manipulate the node through the script. So position, this one, the position of our gym, that y, the y is equal to position that y plus the speed. Let's say we'll give it a speed of 200 pixel, and let's make it smooth by multiplying it to delta. Right. Okay, let's run this game. Hopefully, yep, the gym is falling at the bottom of the screen. If you're a beginner to Godot, you've just made your first object moving. Okay, let's close this first. Here I'll explain this position refers to the position of the gym. So we've just manipulated that, the y-axis, meaning the y-axis here in the game, here, the y is at the top and the bottom, and here is the left and right. So in the game, in Godot, to move to the bottom, will use the positive sign, and to move upward, we'll use the negative. Sorry, the negative. And in the x-axis, this one is negative to the left. We can use this in the paddle node later on, and the right is the positive. Okay. We assign the position to the current position plus the 200 times delta. So as I've said, the process keeps moving every frame. So as it keeps moving, it's reposition the gym, making it moving downward. Now we are going to handle things that if it leave the game scene, we're going to put condition here. If sorry, first there's actually a syntactic sugar for this one. We can comment this one first. Let's copy this, comment this one. We can delete this position, just plus equal to this one. This code is similar, is equivalent to this code, but much shorter. If you play that, yep, the gym is still falling downward. Now let's make a condition. If sorry, if position that y is greater than the y-axis, the whole axis of your project. Let's say you can see that in here, this is your x-axis and this is your y-axis. So your x-axis is 648 pixel. For me, my x-axis. See what is your x-axis and condition that in here. If the our position of the gym is greater than 648, then for now uh let's print the gym falls down at the bottom of the screen. Save that and then play again. If it falls down, as you can see, this process keeps calling it, and it keeps calling. It will make our game crash if we don't do something about it. So let's stop it, and right, it costs 539. information. So here, if a position is greater than 648, it hidden the gem is already hidden at the game scene. We'll just make it we'll make the process stop. So to do that, built-in method in Godot inherited from Node 2D, which is set process, and then it will have a boolean false. Basically, we'll stop this process when the position of our gem hits 648. Plus that, save that and run again. Yep. If you see the gem falls down at the bottom of the screen, it just calls once and then stop the process. But you may notice that it's not our gem is not totally hidden. Let's fix that. Let's move from script. Let's move from 2D scene from the gene. You may notice that it is at the middle. To fix that, we can actually move this to here, and same to our collision shape 2D here. Zoom in. All right. Let's move a little bit. Move a little bit. Okay, let's save that and run again. See, yep, it's totally hidden now and it just calls once. That makes our game a bit faster. Let's stop this, go to script again. And there's another problem with this one. If you go to the game scene, run the project again, go to the remote here. The the gem was hidden, but actually it's not totally destroyed. It's because here at the remote you can see the gem still there. To make our game more efficient, we are going to delete this gem scene from our game scene if the gem is hidden or falls at the bottom of the screen. So to do that, set press false. We can now comment out or delete this print. The shortcut of delete is just click Ctrl X, then the whole line will be deleted. After the set process false, the process will stop once it reaches at the last line of code. To delete these gems in after the process stop or after the position of our gem hits at the very bottom of the screen, we'll call this queue free. This one. This will going to free up the gem node to the game scene here. So if we run again this project and observe in the remote here, sorry, in the remote here. Let's run this again. See in the remote, there's a gem, but if it hits at the very bottom of the screen, the gem was removed here. So it's no longer there. The process stopped and the gem is no longer there. Alright, before we move to the next step, we are going to clean up this code a little bit because there's some hard coded here, like the speed and the 648 position. We can make the speed a constant variable here. We can define here as speed, and it is a constant because we won't let the speed changes in this game. And to define a variable which is constant, we in GDScript we will going to use a small um big letter case speed. It is a float variable, a float type. We'll assign the 200 here and then use that in here. If this speed is uses on different part of this code, and if we need to change that, then we can just change this in here instead of changing all of the speed one by one, which might cause a bug like that. And this 648, it shouldn't be hard coded also. In Godot, we have a built-in method to find the end position of y-axis of our game. The name of that the name of that method is get viewport viewport rec. Basically, it gets the viewport our viewport, this one here in game, gets the viewport, access the properties of it, our viewport, and will specify the end of our y-axis, something like that. It is basically the same with the 648, and we can actually print that in our setup function here, or ready function here. You can say print the end axis of our viewport. Let's click play. As you can see, it has a value of 648, the same value to which we've hard-coded this get viewport rect. What we are going to do now is to add a script for this paddle for it to move from left and right. Now I'm going to pause the video and try to add script to this paddle. It is same with how we add script on this gym. Alright, let's add the script on this paddle scene. Just click the paddle here and click the script. Leave everything as default except this one. Big letter P paddle. Let's create the script. Now it is a template given by Godot. What we are trying to do now is to add the script, um, add the logic for this paddle here to move from left and right. To do that, before we actually head over to this coding here, we are going to register the case that we are going to use in this paddle script. Go to project settings and go to input map. Here you can add a new action. Click this add new action here and name your key. Say let's name it move left, in which our paddle we're going to move left. Click add, and then let's add another one, move right. Click add. In here you can add and register the left arrow key or any key in your keyboard that you want. Add this plus here. And if I click the left arrow key, it will going to listen. And here, click enter. Okay. And now add the right key also. Click this add and click right arrow key. Now we've registered the input move right and move left. We can now close this one and head over to our paddle script. Now if we are going to save that, we can see that this paddle have now the script which they are attached, meaning all of the properties of this paddle we can now manipulate it through this code. The properties of this paddle like the position, rotation, or any other properties. Now to do that, we'll create a condition here. If input that we'll just access the inputs that which we've registered recently is action press, then select the registered name, in this case move left. If it is true, then we're going to manipulate the position of our paddle so that it will move to the left side of our screen. Now moving to the left side of our screen, we're going to use negative here, and then moving to the right side, we're going to use the positive. Here, the position of the paddle, x position of the paddle, being minus equal to the speed. Let's give it a speed of 400, and then we are going to multiply it by delta. Let's run the project and test it. All right. Our paddle is moving now to the left side of our screen. Now I'm going to pause the video and try to move the paddle to the right side of our screen. By moving it to the right side of our screen, we'll just copy paste this code and replace it by move right. And this one, instead of negative, it will going to be positive. Here, actually, you can delete this expression here since it's going to be true. But for explicit reason, I'm going to leave it like that. Let's try and run the project again. Now we can now control the paddle by moving left and right. Let's try to run the project again. You may observe that the paddle is going beyond the viewport of our game. It's very weird. So what we are going to do, close this project. What we are going to do is to add a restriction here. Below these movements, we are going to add restriction here. To do that, we'll use the built-in method of Godot from its global scope. We're going to use the clump if method. This one. Here, the clump if method, it will have a value. This is the position of our paddle, and then minimum, which is 0, and then maximum access, the maximum x-axis of our viewport. Now let's do that here. Position.x equals to clump f. We'll call the clump f, and then it has 3 arguments: the value, the minimum, and the maximum. As said, it is the first one is the value, the position of our paddle. The second one is the minimum access, and then the third one is the maximum access. To get the maximum access, we are going to use the get viewport. We've done that here in our GDScript. Here, we can just copy and paste this one, get viewport, but instead of y, we'll go to get the x. That one, yep, just like that. We have now restricted the movement of paddles in. If we run the project and try to run this, our paddle is not going now anywhere of the beyond the screen. But as you may observe, there's a weird bug here. Um, Half of the paddle's body is hidden. So we're going to fix that. It's actually similar to the gym. Here, to fix that, go to the 2D here and paddle. Then we're going to move the sprite here like that. Same with the collision. Move it here like that. Save and go to script. Now let's run the project. If you move to the left side, it is fixed now. We cannot go beyond the screen. But if we move to the right side, you can see that the body of the paddle is totally hidden. To fix that, we can just we can just deduct the full width of our paddle here. To know the full width of our paddle, you can just go to here in the file system and select this script and select this, texture, double click. Here, this is the width of our paddle, 104 pixel, and this is the height, 24 pixel. Now we are going to use that in the script, deduct that with 104 pixel. Now let's run the project again. Yep, just like that, we fixed the problem. I want to clean up this code. As you may have guessed it, we will going to define speed here at the top, 400, and replace this hard-coded value with speed. And I will also want to show you another global scope that we can use to make these movements here shorter and cleaner. Let's go here to the search help and search for get access. It is one of the method of the input class that we can use. It will accept a negative action and the positive action. Basically, this is the moving to the left side using our left arrow keys and moving to the right side using our right arrow keys. So go back with the paddle script. And then for now, let's comment this out. Something like that. And now let's use the get access, the negative position and the positive position. We will going to change this position X to the input that get access this one. And then what is our negative action? This is the move left. And then our positive action is the move right. We are going to multiply it with our speed. Speed we've just defined at the top. And then multiply it by, yep, delta. Okay, there's something's wrong with here. Let's see what is that. Read okay. It's a indentation. Read the error. An indent doesn't match the previous indentation level. So be careful with that. Save and then let's try to run the project again. Okay, just like that. Our movement is now shorter and cleaner. All right, we have been able to make movements in our paddle left and right. In this lesson, we are going to make the gyms collide with the paddle. By doing the collisions, we are going to use the concept of signals. Okay, so we'll talk about signals before we go to our Godot engine. Signals in Godot are like events. They allow nodes to communicate with each other without being tightly connected. I'm going to explain it. Suppose this is our first node. Signals are Godot's way of saying, "Hey, something happened," and then the other node here can be able to connect or listen to that signal emitted and react accordingly. To further understand that, let's go to our real life analogy. Think of signals like a doorbell. Someone presses the button. This is the events, and when the events occur, the signal is emitted. The bell rings inside your house, the connected function runs, and then the visitor doesn't care who hears it. It is called decoupled. Okay, so someone presses the button, and then the signal is emitted. It will rings inside your house, the function runs, and in the some nodes here, suppose this is you, can be able to listen or connect to the signal emitted. However, the visitor doesn't care who hears it. It could be you, or it could be your mother here, it could be your sister. It doesn't care as long as it just emitted the signals. Okay, hopefully you've managed to understand the concepts of signals because we are going to apply it in our code. Now let's go to why signals are useful. Loose coupling. Nodes don't need to know each other's details. So as I've mentioned earlier, one node can emit the signal, but it doesn't care who will it listen to. Clean code keeps our project organized and easy to maintain, and reusability. We can actually reuse the nodes in multiple scenes since they just emit the signals. All right, let's go to our Godot engine and let's actually apply the concepts of signals. All right, we are now in our Godot engine. Now let's add our last and final script in this tutorial. Let's go to the game scene, and I hope that you are very familiar with that already. Let's add the script here. Let's change it to big letter G. Okay, these are game script. For now, let's clean up this code. We don't need that for now. To add the signals on this game scene, to add the signals in this script, um, go to your right side on the engine and click the node besides the inspector. Click the paddle here, and as you can see, this is the signals that I'm talking about. This is the built-in signals of Area 2D node. This is an Area 2D node because, as you may remember, the paddle and the gym is an Area 2D node. So this is the built-in signals that we can use. We will care only on this area entered. These signals will emit when the receive areas enters this area. Okay. To connect this, just double click or right click, then connect. And then make sure to click this game and then the name, just leave it be. On paddle area entered, let's connect this one. Then as you can see in our paddle nodes, there's a signal icon appear, meaning this paddle has a signal. And then this one here, green, is indicates that it is connected in this script. This one also, you can click this green icon. You can see the source, paddle scene, and then the signal name is area entered. The target is this game script. Okay. To test this one, you can actually print something. Let's say collision and collision with this area. Let's say what it collided. Okay, let's run the project. And if this paddle collided with the gym, you can see that this collision, this one here collision, and in the area, the gym entered. We can add to do here. To do, if the gym entered with the paddle area, we can add scoring system. We are going to get back to this one later, and we can add the scoring system. And if these signals are, or if these functions will run also, we can add sound, add a collect sound. So let's define that in here, add collect sound, and we'll get back to this one. Add collect sound, this one, and let's go back to the gym scene. Again, similar to connecting with this one, similar to the connecting signal, you can just click the gym here and then the node, click this area entered again, and then connect the signals in this gym script. Let's connect this one, and then right, we can print this one. Let's say gym hits the paddle. Okay, if this function will call, or if the signals emitted, the gym hits the paddle. Let's test this out, run the project again, and then if it hits the paddle, yep, gym hits the paddle, so it works. Now I want you to make the gym be deleted or stop this process if the gym hits the paddle. I'm going to pause the video and try to do that. All right. Actually, we already have this code here. If the gym hits the paddle, we can just stop the process. I mean, set process false, and then we can delete the gym node. Let's comment this out, and then let's try to run this again. If the gym hits the paddle, okay, it is deleted and the process stopped. So you can see in the game, there's no gym here. Okay, I want to show you something in our game. Let's This function will also apply even if we duplicate these gym nodes. So let's try that in the game. Try to duplicate the gym 2 times. So we have now 3 gyms in our game scene. Go to the Toadie node and reposition the gym. Let's save this and try to run the game. Now we have 3 gyms falling. Oh no, we have to make this. Okay, this one, if it's collect. So as you can see, even though we've just this functions here, it actually applied to all the gym that is being duplicated in here. So I'm just showing you that because later in this video, we will actually spawn multiple gyms at an interval point. Okay, let's delete this one. We don't need that. Save the game. Alright, you just make the gym hits the paddle and you just make the gyms disappear. You may see that some of the code is redundant here. The best practice of that is we can actually create specialized function for that. Let's call it die with a void. We can copy and paste this code here, paste it in our die function, and we can reuse this function if we want to set the process to false and we want to delete the gym scene. We can call this die function here instead of repeating our code over again. We can use this. Let's delete the comment also and paste the die function. Okay, they're just basically the same. We're just cleaning our code. All right, we've managed to add 2 built-in signals in our game. The first one is in the game script, the on paddled area entered, which we have 2 to-dos. We'll come back to this later. And the second one is in the game script. You'll know that this is a signal because you can see this green icon here at the left of our function. And in this lesson, we are going to introduce custom signals. Okay, so we can actually create custom signals in Godot Engine. The reason for this is we want our node, this gym node here. We want our node, this gym node, to announce that something important happened. Okay, so to create a custom signal in Godot, it is pretty straightforward. Use the Godot signal keyword, say body of screen. So it means the body or the gem is at the bottom of the screen. So later on, it will create a game over logic. And then we are going to emit this something from some events. So the events is if the position or the position of our gem is at the bottom of the screen. So we can emit this in here. Emit. Okay, we have the body of screen that emit. And right now we are ready to use this body of screen custom signal. And I forgot, if you go to the right side of your IDE, you can see that we have now this body of screen signal. This is a custom one, and these are the built-in signals, and this is the custom signals that we've just created, which we've emitted here if the position of the gem is at the bottom of the screen. So we're going to call this signal in our game script here. Go to the game scene and then click this gem. We can actually connect this body of screen here. Let's connect on gem body of screen. Let's leave that. Make sure to connect this game scene. Connect. And right now we have two functions on paddle area entered and on gem body of screen. Let's test this out. I've said that this would be a game over logic. Let's print game over and run our project. Stop, run our project. If the gem hits at the bottom of our screen, it will say game over. So it works. Our custom signal works. Okay, let's just add to do here to what should be done so that we can't forget it. Add game over logic. And I also observe we have the 648. I think it's on the gem screen. Let's clean it up. Okay, here. We don't need the sprint now. And then let's just type pass so that we will avoid some errors. And also in the game, since we know that this is for the collision of the gem, we can actually comment that and type pass also. So if we run the project again, and then if the gem is at the bottom, then it's game over. Alright, now we are going to spawn the gem at a given interval. To do that, we are going to add another node. Okay, click on the root node, add another node. The name of the node is timer. Okay, timer. As you can see at the left side in here, we have this built-in signals timeout. We are going to use that. Click on this timeout, double click, and make sure to click these games in here. Let's go connect. And here, if we click this timer and go to your inspector besides the node, we are going to use this wait time. The gem should spawn it at 2 seconds, and we are going to change this auto start also to on. So if the game runs, this timer will auto start. Now let's change this wait time to 2 seconds here, and then we'll auto start this one. This is the properties of the timer. So we have to we, first we'll test this one if it's work. 2 seconds, let's say 2 seconds had passed. All right, let's run our project. And every 2 seconds, okay, it should output in our console. So as you can see, this function on timer timeout invokes every 2 seconds. Let's stop the project. And to spawn the gem, we are actually going to delete this gem node here inside our game scene, because we are going to instantiate this gem using our script inside our script. Okay, so we have to delete this node, and to instantiate the gem, it's actually pretty easy. Go to your file system and find the gem scene here. Make sure it is the gem scene here, not this gem.gd. Okay, to instantiate that, just drag and drop it into your script. But before dropping, make sure you press the Control K, and then Godot will payload the gem for us. Okay, make sure to press the Control K. After that, we are going to first get back the ready function that we've deleted recently. Void. Okay. And then we have to create another function. Let's call it spawn gym because it's going to spawn the gym. By spawning the gym, we have to create a variable here. Let's name it new gym, and then we are now going to instantiate this gym. Just copy this gym that instantiate like that. Okay, and we are going to call this spawn gym inside our ready function. As you may remember, this ready function will only run once the this node is entered into our scene tree. Okay, let's call this spawn gym here, and then we'll define the exposition of our gym. Let's say for now, I forgot the float type. For now, let's hard code it. Let's say the exposition is at 300 300, and we'll have to put the position in our viewport by this code. This vector 2 will have a x and y value. So the x value is our exposition and the y value is should be negative. Why is this negative? Because we want our gym that it shouldn't be seen in our viewport. So it should be somewhere in here. Our gym should be somewhere in here. So at first it shouldn't be seen in our viewport. Let's go back to the script and let's now where's that? Let's now add this child into our node scene. Let's add this new gym, and then of course we are going to call this spawn gym in here every 2 seconds. So let's replace this and call this spawn gym. So the expected output here that is every 2 seconds this spawn gym will be called this one. So let's try this one and run the project. All right, now every 2 seconds you can see the gym spawn at a regular interval, which is 2 seconds. But yep, it just spawned at a very same position. It is because we are just hard coded the exposition. So we need to apply a random range for that. And the Godot has a function ranDifRange, a global scope. It returns a random floating point value. So from this is the minimum value and then to our maximum x-axis for that. Now let's go back to the gym, to the game script, and let's actually call that ranDifRange. Um, the from or the minimum value is 0, and then 0 to the very end of our x-axis. So we've done this before, that end, that x. All right. Now this x position has now a random value. So if we run the project, as you observe, this gym now is spawning randomly at 2 seconds interval. All right. Let's run our project again. As you may have noticed, when the gym falls off at the bottom of our screen, falls at the bottom, we can see the game over in our output. So this function here does not invoke. Why is that? Mm, okay, it is because before adding the new gym, we have to connect this function in our gym instance. So here, new gym, we have to call the custom signal in our gym. The name of the custom signal is body of screen. Then body of screen that connect. We have to connect this function here. Just like that, run the project again, and we should see the game over text here. All right. Okay, now let's add a game over logic here. when this function invokes. So we are going to replace this game over text into our actual game over logic. But before that, let's add a variable type in our gym in here because we are going to use that later. So here in our gym script, we name the class name as gym. So if you've noticed, when you click this add here and then type gym, the gym is actually registered as a node. But if you type paddle, the paddle, there's no paddle in here. So gym, there's a gym in here. So meaning it registered as a node. And whoever instantiate this node, gym node, we can use this like this. Okay. Now let's go and add our game over logic. To add that, we have to create another function. We'll name it game over logic. Okay. So it will be called in place of this text. So in the game over logic, we want our we want our paddle to be stop moving, and we want this gym here to stop moving also. Okay, close that. Now let's first stop the time. Um, we don't have a reference of the time in here, so to add that, just drag and drop again for this timer in here. But before dropping, uh, press the Control K, and we can actually use this timer now. This timer, and we have to stop this one. Stop. So this function will now stop invoking if this game over if it is game over. So and we have stopped the time. Also, we have to stop the gym from falling. To stop the gym from falling, since there will be many gym because we have spawned this from a given interval, we are going to use a loop in here in get children. So literally it will get all the children of this node. Then if that child is a gym, like I've said, we will use this gym. If the child is a gym, then we are going to stop the process. Uh, Stop the process, set false. So if the child is gym, then it will going to stop the process if this game over is invoked. Okay, let's copy this game over function in here. So let's comment this, and we have to replace this to do because it's done now. Game over. Now if we run the project and if it falls below the screen, all right, the the gym stop moving, and then the timer also stop moving because we've stopped it. However, we can still move the paddle, so we are also going to stop this paddle from moving. Okay, to stop the paddle, we can use this set process false also, but we don't have a reference yet, so let's drag and drop this paddle, press Ctrl K, and we can use this paddle now in, sorry, should be like that. We can use this paddle now in here. Paddle, that's it. Process to false. Now let's run the project and test it. Okay, if the gym falls off the screen, then the gym stop, the timer stop, and also our paddle stop. So if you try to move our paddle, we cannot move it because we've stopped the process. Now let's add sound to our game to make it more interactive. To add sound, it's almost identical to adding a texture graphics into our node scene. Click the root node and add the sound here. Type audio. We are going to first add the game track of our sound. So click this audio streamer, create, and this audio streamer, we are going to drag and drop our game sound assets in here, which is the game track. Click this audio streamer and drag and drop here in our stream, this one. And we are going to autoplay this stream, and we are going to loop this one. Here in the parameters, we are going to loop this, and we are going to autoplay this. You don't need to reduce the sound, but for me, I'm going to reduce it because I'm using a headphone. It might be too loud. Right, that, just like that. Click save and play the game. You should be able to hear our game sound. Okay, as you can see, if the gym hits at the bottom of the screen, we want to stop the sound also. To do that, we are going to reference this audio stream player, but first let's rename this to game track sound. So we'll know that this is our game track sound. It's going to reference this. Drag and drop. This game track sound should be stopped when it's game over. So here at the top, game track that stop. We're going to stop it like that. Run the project again. If you see, if we're going to the bottom of the screen, then our sound also stop. Okay. Now we are going to add the collect sound to our game. You can just select collect 1 or collect 2. It's an option for you to select this one. To add the collect sound, we have to add another node. And again, it would be an audio stream player 2D. So we have to click this one, create this node. We'll name it let's say collect sound, like that. And here in the inspector, here in the stream, we are going to put this collect 1 or collect 2 here in this stream. So drag and drop here. I'm going to select collect 2, drag and drop here in the stream. And we have to add here somewhere if, yeah, we actually add it to do here. So we are going to add collect sound in here. But before that, we are going to reference this collect sound so that we can use it. Drag and drop, collect sound, then here add collect sound, we'll just say that play, something like that. Sorry, before the collect sound that play, we are going to set the position, collect sound that position to its area that position, and then collect sound that play. It should be able to add the collect sound to our game. Let's play and test the game. Now, if the paddle hits the gym, all right, we've implemented the sound, both the game track sound and the collect sound. But if it's game over, then it's going to stop our game. If it's going to stop our game, it would be nice if we add a explode sound also. We have an explode sound in here. This one, explode.wow. To add that, it should be added here in our game over. So somewhere in here, we have to add this explode. To do that, we are going to reference this explode in here by dragging and drop while clicking the control. We have to click this explode. In the game over, you can see you have stopped the game track that sound. Now we are going to stream the explode that we've referenced, this one explode, and then we are going to play that sound, game game track sound that play. So what we're going to play in here is not our game track sound but the explode, which we've added this condition here, this expression. If it is game over, then the game track that sound will stop and the explode sound will play. Let's run our project and test that one. If the paddle hits the gym, it will make a collect sound. And if it falls at the bottom of the screen, alright, did you hear that? It explode. So our game sound is finished now. We can now delete this to do because it's finished. Alright. Okay, we've now reached in our final section, which is adding a scoring system. Here we are going to implement the logic for adding a scoring system. But before that, we have to add some text in here at the upper left corner of our viewport. To do that, click this root node and add a label. Okay, click this label and we'll rename it as score label. And then here at this inspector in the text, we can add here a 000 and scroll down find these theme overrides, and we have to increase the font size. We'll increase it to like 48 pixels and place it in here. And you can actually um, update its style also by doing the here on these colors, like update the color. We have to update this font color. You can do this on your own. Just explore it. Can update the font shadow, something like that. Okay, it's up to you how you'll make the label looks like. You can explore your creativity in here. But for me, I guess that's it for me. So let's now go to the script and add logic for scoring system. Okay, we have to reference this score label because we will going to use this later, and we have to define the class level score default 0, and we will going to increment this score if the paddle hits the gym. So going to find that we're going to find that function, this one, on paddle area entered. We can actually clean up this comment and pass, and we are now going to implement the here in the to do. We are going to increment the score if this function invoke or if the gym hits the paddle. Okay, so to increment the score, we'll do something like that, increment by 1, and we are going to display it in our score label in here, this one score label. We're going to call it and score label that text is equal to this score. Okay, however, if we save this one and we'll run this project, it's not going to increment and we've crashed. Why is that? Let's first stop this game. It is because the score is an integer, type of integer, but our score label, this one, is a type of string. So we are going to convert this score into into string. By doing that, we can just say string, something like that. So this score is now a string. So if we play this one, play the game and collect this gem, you notice that our score has been incremented. However, it's become a one digit, so we are going to format that. It is same as formatting in Python. You can use you can go to the official Godot website for the format strings, but here we are going to use the percentage %d. This one we are going to use the t for decimals and 3 padding. Going to format the score. So what will happen this one is this score will now going to be look like this, 3 digits. Okay, let's run our project and see if it works. Okay, so it completely works now. Our score here, it displays properly. Okay, what we are going to do now, actually it's now playable. But what we might want to do now is that if we are game over, we might want to add some sort of button in here, like a restart, so that if it is clicked, then we will going to restart the game. Okay. So to do that, let's click on our root node here and add another node, a button. This one, we'll call it a restart button. And here in the text area, let's call this restart, and we'll place it somewhere at the middle of our viewport. Yep, just like that. Let's increase the theme size by going here in the theme overrides and select these font sizes. We'll give it a like 52 pixels like that, and here in the screen, normally we're going to reference this restart button, add reference in our script. So this restart button will going to be if it clicks, then it will emit signal to restart our game scene. So to do that, we've discussed this already. Click this restart button and go to this node besides the inspector. We have a built-in signals here in our restart button node. What will concern is this press. So if this button is pressed, then it's on restart button press, then it's going to restart our game scene. So we are going to reload our current scene, get 3, that reload our current scene, this one. Okay, let's run our project, and if the gym fall off the screen, then it's game over, and then if we click this restart, then we can play again. Alright, but as you've noticed, the restart button is always on display, so somehow we are going to hide this if we're still playing. So for that, I'm going to pause this video and try to do that on your own. Alright, let's do this together. We're just going to hide the restart button if it's first enter the scene. So by to do that, we're going to say to take the visible to false here, restart button that false, and we are going to make it true if it is game over. So let's find the game over function here, game over. Copy this one at the bottom in here. I'll say restart. Show the restart button. Okay, we're going to show the restart button if this game over here will invoke. Okay, let's run our project again, and let's play the game. All right, let's collect some gems, and if we're able to miss collecting the gems, then this restart button here appears. And if you click this, okay, we've run the game again. All right, okay, we've finished building our gem collector game. And if you've reached this far, congratulations! You've explored the basics of Godot Engine and implemented some of the most common 2D nodes used to build any 2D games. And if you're new to game development and watching this tutorial, you might have built your very first 2D game, so congrats with that. Just a quick note, you can always go to YouTube timestamp and rewatch the section that you want to understand. Thank you so much for watching, and see you next time.